Previously, we looked at the quadratic equation and found that the x-intercepts are also known as the roots. We will be extending this knowledge by answering the quadratic inequality. We will also be using the number lines to help us solve for a range of values that will satisfy multiple inequalities. So prepare your pen and paper and let us begin. Like equation, inequalities are just mathematical statements, but instead of using the equal symbol, we represent it with one of four notations, namely more than or equals to, less than, and less than or equals to. These notations can be applied to a quadratic expression. Let us focus on the cases for strict inequalities. If the quadratic expression is greater than 0, then we will take the range of x that are diverging to the extreme ends. Conversely, if the expression is less than 0, then the range of values will be converging. We can try to imagine this with a balloon. Let us represent the balloon as the quadratic expression. If the expression is greater than 0, then it is like blowing a balloon and making it big. As such, the range would start from the roots and move outwards. On the other hand, if the expression is less than 0, then it is like trying to compress the balloon and making it smaller. As such, it will be the values that are sandwiched between the two roots. Let us try to solve for a quadratic inequality. We want to find the range of the value of x that satisfy the quadratic function. So, we will first make the right hand side be equals to 0. Then, by factorizing, we will be able to find for the roots. Next, we will want to do a quick sketch of the quadratic curve, and since it is less than or equals to 0, the values of x must sandwich between the two roots. As such, the range of value of x will be between 2/3 and 3 inclusive. In the last lesson, we discussed that the discriminant of a quadratic function will reflect the nature of the roots. While this is quite intuitive, students who recently learned this might get confused. As such, I will illustrate this using some absurd imaginations. Let us assume that the discriminant b squared minus 4ac represents the mass of an object and that the mass of a human being is the base level. As such, when the discriminant is equal to 0, it only touches the x-axis once, just like how when we can only be standing at one point on the ground. On the other hand, when the discriminant is less than 0, we can imagine that the mass is negligible. Just like a ghost, it floats and does not touch the ground. Moreover, where the discriminant is greater than 0, it is as though the mass is extremely heavy, just like a whale in the ocean. Since the whale can swim up to the surface and dive back in, it produces two ripples. Likewise, a quadratic graph with positive discriminant would only produce two roots. Let us answer an example. We want to find the range of value of k such that the quadratic equation has no real roots. This means that the graph does not touch the x-axis and so the discriminant is negative. By substituting the value and simplifying it, we will get k to be less than negative 25 divided by 8, and that is the required range. Sometimes we may be presented with multiple inequalities and are asked to find a range of values that satisfy all the given inequality. To help us locate for the range, we can make use of the number line, which is just a straight line with the number placed at equal intervals. Let us take a look at the example to show how to present a solution with a number line. We are given a quadratic expression that lies between plus and minus 2. To approach this, we can rewrite this as two separate inequalities. Then, for each inequality, we will want to make one side of the expression to be 0. This will give us x squared plus x minus 2 to be greater than 0 and x squared plus x minus 6 to be less than 0. Just like how you go about solving for quadratic equations, we can factorize the expression and then represent the inequality using a quadratic graph. For the inequality on the left, these will be the values that are smaller than negative 2 or greater than 1. While for the inequality on the right, it will be the values between negative 3 and 2. With this, we can use a number line to show the required inequality. The solutions will be the values that satisfy both the inequality. We can view this as a shadow when shining a torchlight from above. Where the so-called shadow intersects, that would be our solutions. As such, from our number line, we see that the range of value of x are that which lies between -3 and -2, as well as those that lies between 1 and 2. Let us wrap up what we have learned so far. We know that inequality is like equation that relates two mathematical expressions together using one of four inequality notations. We also learned to solve for quadratic inequality where the range of value of x differ depending on the notations. This is illustrated with the blowing and squashing of our quadratic balloons. Furthermore, we recap on the discriminant of the quadratic functions, where the discriminant would give us the nature of the roots. Lastly, we employed the number line when finding for a range of value of x that would satisfy numerous inequalities that are presented.